In this video, we'll be covering moles and amount of substance for paper 1, made simple, clear, and exactly how the examiners expect it.
Reactant masses is one of those topics that makes GCSE students panic until you realise almost every question follows exactly the same process. In this video, I'll show you the 3-step method, limiting reactants, gas volumes, and the mistakes that lose the easiest marks. Let's get into it. Nearly every reactant masses question follows these 3 steps. First, convert to moles. Second, use the ratio from the balanced equation. And third, convert back into whatever the question wants. Mass, gas volume, particles, anything. Memorize these 3 steps and suddenly reactant masses become much easier. Before you do reactant masses questions, always check the balanced equation first. The balanced equation tells you the mole ratio. Those numbers in front are called coefficients. They tell us how many moles react and how many moles form. Get those numbers wrong and every calculation after that becomes wrong. So before touching a calculator, balance first. Let's look at the example. Magnesium reacts with hydrochloric acid. Magnesium plus 2 hydrochloric acid produces magnesium chloride and hydrogen. Ignore everything else for a second and just focus on the numbers in front. 1 magnesium, 2 hydrochloric acid. That gives us a ratio of 1 to 2. So for every 1 mole of magnesium, we need 2 moles of hydrochloric acid. This ratio is what we'll use in step 2 of reactant masses calculations. Let's lock the process in one more time. Convert, use the ratio, convert back. Don't skip steps. Students often try to jump straight from mass to answer and chemistry responds by stealing marks. Step 1 is converting into moles. The formula is number of moles equals mass divided by relative formula mass. For magnesium, 6 grams divided by 24 gives 0.25 moles. This step matters because the balanced equation works in moles, not grams. Now use the ratio from the balanced equation. 2 magnesium plus oxygen produces 2 magnesium oxide. Notice magnesium and magnesium oxide both have a coefficient of 2. That means the ratio is 1 to 1. So if I have 0.25 moles of magnesium, I also make 0.25 moles of magnesium oxide. Now convert back into whatever unit the question asks for. To find mass, mass equals moles multiplied by relative formula mass. So 0.25 moles multiplied by 40 gives 10 grams. And that's our final answer. Limiting reactants are simply the reactants that run out first. Once one reactant is gone, the reaction stops. Even if you still have loads of the other reactant left. That limiting reactant controls how much product you can make. Imagine sandwiches. You need 2 slices of bread and 1 slice of cheese. You could have 100 slices of bread, but if you only have 1 slice of cheese, you can only make 1 sandwich. Cheese is the limiting reactant. Chemistry works exactly the same way. For calculations, convert everything to moles first. Use the balanced equation to find the ratios. Then divide the actual moles divided by mole ratio. Whichever reactant gives the smaller value is the limiting reactant. Smaller ratio means limiting reactant. For gases at room temperature and pressure, 1 mole of any gas occupies 24 cubic decimeters. Memorize that number, 24. Hydrogen, oxygen, carbon dioxide, any gas, 1 mole equals 24 cubic decimeters. Let's try an example. What volume does 0.5 moles of oxygen occupy at room temperature and pressure? Use volume equals moles multiplied by 24. So 0.5 multiplied by 24 equals 12 cubic decimeters. One of the easiest ways to lose marks is mixing up cubic centimeters and cubic decimeters. 1000 cubic centimeters equals 1 cubic decimeter. Check the units before putting your answer down. Students lose mark here every year. No donations are required for the exam board. Common mistakes: ignoring the ratio, using the wrong relative formula mass, forgetting units, skipping the mole step completely. Most mistakes aren't because the chemistry is hard, they're because the process wasn't followed. Reactant masses really comes down to one system: convert, ratio, convert back. Learn that process, and suddenly questions that looked impossible become predictable.